We have always wondered if there is life in the depths of the universe. But what if I told you that the possibility of more life forms existing is more certain than ever before? This could be a discovery that fundamentally shakes our understanding of the universe. The new James Webb telescope acts like a time machine, able to look back to the very formation of the universe. It has discovered 6 shocking galaxies that defy all explanations. The James Webb telescope has detected 6 galaxies that existed just 500 million years after the beginning of the universe. These galaxies are 10 times larger than the Milky Way. This major discovery prompted Michio Kaku to break his silence about the James Webb telescope. The shocking discovery shows that building a galaxy is no easy task and that the age of the universe exceeds 350 million years. It took years for the first galaxies to form, and they were quite small, taking a long time to become the galaxies we know today. However, scientists have discovered 6 ancient galaxies that break all the rules. These galaxies had populations of tens or even hundreds of billions of stars just 500 million years after the Big Bang. American theoretical physicist Michio Kaku is astonished by this groundbreaking discovery that could change everything we know about the universe. The James Webb Space Telescope, a $10 billion project launched by NASA in December 2021, has detected 6 massive galaxies, each roughly the same size as our own Milky Way. These galaxies formed very early in the history of our universe, and some stars in these cosmic objects have masses not just several times, but billions of times greater than our Sun. If this information hasn't impressed you enough, one of these objects could have a stellar mass 100 billion times that of our Sun from the perspective of the Milky Way. Our beloved Sun, in comparison, has a stellar mass of only 60 billion times. This discovery is truly mind-boggling, and as expressed by Erica Nelson, one of the scientists working on this project, her astonishment and excitement are immense. These new findings are set to fill major gaps in our knowledge. This latest discovery is like a puzzle piece you don't know where to fit. The team of astronomers who detected these galaxies has named them universe breakers, because if these galaxies are real, we will need to reassess all our understanding of galaxy formation. This discovery could lead us to question some fundamental rules of cosmology, so be prepared for some exciting new information about the explanation of the universe. Have you ever wondered what the universe was like when it was just a tiny part of the galaxy? The widely accepted Big Bang model tells us that the universe was born 13.7 billion years ago as an extremely hot and dense point, and it expanded to its current vast size. But what happened next to shape the universe as we know it today? The universe, which originated from a single point and expanded at an incredible speed in its initial growth spurt, cooled as matter formed. Then the universe experienced a magical moment called recombination, when electrons combined with nuclei to form atoms, and the universe became transparent. Then, interestingly, came the Dark Ages, a period before stars and galaxies emerged. Between 150 and 400 million years later, the universe began to emerge from this darkness during a period known as reionization. The Big Bang and the formation of our solar system followed this period. However, these newly discovered galaxies appear to be about 13.5 billion years old, meaning they started forming around the Dark Ages. The fact that these galaxies are so large contradicts 99.9% of the cosmological models that scientists have constructed. In this case, either the models will need to be adjusted, or we will need to completely reassess what we know about galaxy formation in the Dark Ages. The discovery of such large galaxies so soon after the Big Bang suggests that the Dark Ages might not have been as dark as previously thought. Thanks to the intense efforts of scientists, we now know that star formation began much earlier than previously believed. The Dark Ages lasted from approximately 380,000 to 150 million years after the Big Bang, and we understand that stars began forming toward the end of this period, around 180 million years after the Big Bang. However, for the universe to become what it is today, these new galaxies would have needed to create hundreds of thousands of new stars every year. This discovery jeopardizes all our understanding of our universe. The farthest galaxy discovered by Hubble was GNZ 11, but now the discoveries of the James Webb telescope might change this understanding. It could fundamentally shake what we know about cosmology and require us to reevaluate everything we know. Further studies on the Milky Way already hinted at how quickly stars emerged after the Big Bang. Perhaps the discovery of these galaxies was only a matter of time. Then, interestingly, came the Dark Ages, a period before stars and galaxies emerged. Between 150 and 400 million years later, the universe began to emerge from this darkness during a period known as reionization. The Big Bang and the formation of our solar system followed this period. However, these newly discovered galaxies appear to be about 13.5 billion years old, meaning they started forming around the Dark Ages. The fact that these galaxies are so large contradicts 99.9% of the cosmological models that scientists have constructed. In this case, either the models will need to be adjusted, or we will need to completely reassess what we know about galaxy formation in the Dark Ages. The discovery of such large galaxies so soon after the Big Bang suggests that the Dark Ages might not have been as dark as previously thought. Thanks to the intense efforts of scientists, we now know that star formation began much earlier than previously believed. The Dark Ages lasted from approximately 380,000 to 150 million years after the Big Bang, and we understand that stars began forming toward the end of this period, around 180 million years after the Big Bang. However, for the universe to become what it is today, these new galaxies would have needed to create hundreds of thousands of new stars every year. This discovery jeopardizes all our understanding of our universe. The farthest galaxy discovered by Hubble was GNZ 11, but now the discoveries of the James Webb telescope might change this understanding. It could fundamentally shake what we know about cosmology and require us to reevaluate everything we know. Further studies on the Milky Way already hinted at how quickly stars emerged after the Big Bang. Perhaps the discovery of these galaxies was only a matter of time. Although most of these celestial bodies are currently identified as galaxies, scientists do not rule out the possibility that some of them could be massive quasars or supermassive black holes. However, this raises even more questions about the existence of such large quantities. Explaining the concentration of mass in a single point in the early universe is quite challenging. If these objects are indeed supermassive black holes, it could mean that our understanding of black holes needs to be reassessed. We already know that supermassive black holes are found at the centers of galaxies, but the idea that they could have formed so early in the universe challenges current theories. Hubble had previously discovered very ancient galaxies like GNZ 11 and CAMZ 13. Last year, JWST discovered the oldest galaxy ever observed, the galaxy CAMZ 13, which existed 300 million years after the Big Bang. Yes, we are talking about a galaxy older than 13 billion years. This discovery is one that astronomers could hardly imagine. This could rewrite the first pages of cosmic history because CAMZ 13 is not an ordinary galaxy. Despite its age, it has a mass of 1 billion solar masses. However, its size is smaller than the Milky Way. While the Milky Way is about 100,000 light-years wide, CAMZ 13 is only a few thousand light-years across. Additionally, scientists have discovered another ancient galaxy nearby called CAMZ 11, which is almost the same age as the previous record holder, GNZ 11. In 2016, astronomers using NASA's Hubble Space Telescope created great excitement with the discovery of GNZ 11, the most distant galaxy observed in the universe to date. GNZ 11 formed 13.4 billion years ago, extending to only 400 million years after the Big Bang. Although GNZ 11 is 25 times smaller than the Milky Way, it contains only 1% of the stars of our galaxy. However, rapidly growing GNZ 11 forms stars 20 times faster than our own galaxy. These findings provide new clues about the very early periods of the universe. Following Hubble, the James Webb Space Telescope took on the mission of capturing more detailed images of the early universe. This powerful space telescope uses infrared technology to detect objects in the early universe. Infrared light is ideal for detecting faint light that has expanded over billions of years and spread to longer wavelengths. This expansion is known as redshift. So, what is redshift? When we observe light from distant galaxies, we notice that this light, despite being emitted a long time ago, has taken on a slightly redder tone, Light waves expand in space and the color of the wave shifts to red. This causes the wavelengths to reach Earth as longer and redder waves. But why do the shape and color of the wavelength change as it moves? It's not just because the galaxy is moving away from us. Contrary to what many people think, the space between the galaxy and us is actually expanding, pushing the galaxy further away. This discovery turned things completely upside down. When we saw how quickly galaxies were moving away, we realized they were not racing in a fixed space. The more redshift we observe from them, the higher the redshift value, and the farther the galaxy moves away from us. For example, the redshift of Z13 is 13, and the redshift of GNZ 11 is 11. By examining redshift, astronomers can go back to the early days of the universe when the first stars emitted ultraviolet light. This light has since shifted to the infrared part of the spectrum. The James Webb Space Telescope is specifically designed to study these distant and oldest galaxies using infrared. Thanks to its cameras and spectrometers, JWST can look further back in time than ever before and provide us with a view of the early universe that was previously impossible to see. Now that you understand these terms better, let's focus on one last discovery. The Advanced Deep Extragalactic Survey, JADES of JWST, has discovered 4 more galaxies confirming previous distance estimates. One of these galaxies has a redshift value of 13.2, meaning we see this galaxy just 320 million years after the Big Bang. This incredible breakthrough has excited astronomers. And Emma Curtis Lake from the University of Hertfordshire in the UK said they had been waiting for this for decades. Peter Van Dockum from Yale University compared the age of this galaxy to the total time sharks have existed on Earth, which is about 300 million years. It's astonishing to think that we could go from nothing to fully formed galaxies in just the blink of an eye. However, as with all major discoveries, there is a problem here too. Not all candidate galaxies with high redshift are as lucky as JD's GSZ 13. 0. In fact, the Cosmic Evolution Early Release Science Survey led by Finkelstein believed they had discovered a potential galaxy at redshift 16.4, just 240 million years after the Big Bang. However, this galaxy turned out to be a false alarm, discovered with a redshift between 4.9 and 1.2 billion years after the Big Bang. This is still impressive, but does not break records. This shows the importance of caution in the world of astronomy and how even the slightest error can lead to completely different results. So strap in, space explorers, because who knows what incredible discoveries the future holds. One thing is certain, the universe never ceases to amaze us. The future promises great hopes for high redshift studies. The latest discovery by the powerful James Webb Space Telescope is the identification of a galaxy with the highest redshift ever detected at 16.4. This is just one example of the groundbreaking research conducted with this sharp device, and the ongoing study called Cosmos Webb is far from over. It is expected to uncover more high redshift candidates. However, some experts are concerned that the field is advancing too quickly, with astronomers on Twitter seizing open access studies from researchers who have not yet published their analyses. This has not prevented many other astronomers from making proposals to spend extra time on the telescope or submit scientific observations for the upcoming second cycle. Despite these tensions, astronomers are still excited about obtaining unprecedented insights into the early periods of the universe. Perhaps galaxy formation might have started with a redshift of 20. Van Dockum suggests that galaxy formation might have begun just 180 million years after the Big Bang. It is clear that JWST's ability to look further back than previously thought possible is revealing unexpected discoveries that challenge our understanding of the universe. Unveiling its mysteries is proceeding at full speed, with the James Webb Space Telescope leading the charge. Could there be even more groundbreaking discoveries in store? That's a wrap, folks. What do you think about the space puzzles that you will most comment on and tell us about below?